I'm Bob Dahlstrom, founder and CEO of Apellix. At Apellix, we build large industrial drones that are about 3 feet by 3 feet. We have a spray painting drone that's able to spray protective coatings on industrial assets. We have a power washing drone, which in some respect is designed to do surface prep before you paint. And then we have a measurement drone that makes physical contact with the structure to take measurements to measure things such as paint thickness. The goal of the company is to be able to take care of industrial assets from cradle to grave. So when it's new, be able to paint it over time, be able to clean it when it needs to be repainted, measure the thickness over time of the paint, and then repaint it when it needs it. At Apellix, we are all about the software. So we write that custom code that's necessary for that very fine precision and flight control. Drones want to avoid flying into things for collision avoidance purposes. We intentionally either fly into things or fly very close to things, and that's extremely difficult to do. So that's where the value of software comes in. And in part, if you're flying things manually as a human, you see something and make an adjustment to the flight, it takes time. Software in that same amount of time may have made 5 or 50 micro adjustments to the flight. As far as the hardware, we're agnostic. We would love to have a system that was already built, a drone that already worked, and we could put all of our stuff on, but unfortunately none exist on the market. And the technology that we've developed so far that we've seen is so far ahead of other people in this area that we just are focusing on that software and on developing it and continually enhancing it and making it better, so that we can continue to unlock the value of this platform that we've built. To give a little color about where we are currently with Apellix and what we're doing, we've done some field trials with different customers for getting our products into the market. The spray painting drone is still under development, but we hope to be starting probably within 6 to 9 months once we complete some more additional development on that. But what's ready now is our pressure washing system. And we're extremely proud of that. We just won a contractor's award for 2022 with that for a job we did for the city of Wooster, Ohio, where we washed an elevated water tower, 131 feet globe-shaped tower that came down up in the northeast of the US, or Midwest, I'm sorry. You get mold and mildew that grow on the side of these tanks, and about every 5 years you need to clean that off. Or else you have to paint these more often. And so there's a cost associated with not keeping them clean. So what we did today here at our demonstration playground at the back of Apellix warehouse is we built a facsimile of a large truck that the military uses, and we simulated cleaning it. So we took our tethered drone for power washing, and we hooked it up to a standard pump that is used by industry for pressure washing and cleaning, 3,000 PSIs, up to 8 gallons per minute of rinse. And so we were able to fly up and spray water on the truck to clean it off, and to do the front and the side of the truck took probably about 6 or 8 minutes. And we used a standard tip that you would find on a 3,000 PSI pressure washing system. And then we're also able to wash a larger structure that we had built out back. We have a wall that we've built for demonstrating the spray painting drone on. We then moved from the truck to the larger wall and demonstrated how we could wash larger structures with that power washing system. So that was flown manually.
My name is Christopher Lee. I am a software engineer here at Apellix. I joined the company back in May after obtaining my master's from Cornell University in robotics. So what you saw during the demonstration today was first the washing of the truck mock-up using our power washing drone. Following that, we demonstrated the capabilities of our painting drone. This drone is a semi-autonomous drone. Essentially the way it works is paint is pumped up from the grounds through the tether up to the drone. Our drone is designed primarily for painting walls, and as a result, our control system, as far as the automation goes, is fairly straightforward. Essentially, the process just involves having the operator fly the drone up to the desired painting start point on the wall, and then the operator may put the drone into an autonomous mode, which allows the drone to either move vertically or horizontally along the wall, painting a stripe of paint along the wall. And then whenever the operator decides that he or she would like to paint the next stripe, he or she may simply press a button telling the drone that the current stripe has been finished, and the drone will, at the touch of another button, move up or down or sideways, whichever direction needed to paint the next stripe. Really, the three keys to our autonomous system are having a good way to figure out where the drone is in 3D space, figuring out where the target is to be painted, and also having a means to control the drone such that the drone applies the paint to the desired targets with the desired level of thickness. For the localization aspect of our problem, we use a laser-based system called a Leica system. It's typically used for surveying. And this system provides us with an extremely high level of accuracy, on the order of a few centimeters of the 3D position in space of the drone. In more feature-rich environments, in environments with more complex geometries, we could instead rely upon the LiDAR, which is already on our system, to perform mapping of the environment as well as localization of the drone within 3D space. And this hardware and the software that we could develop would allow us to move away from our laser-based localization system.
These drones obviously are large, heavy lift, industrial systems. They're not for, working on houses or architectural coatings and paint. They're more for industrial coatings for assets like in oil and gas or renewable energies or maritime or infrastructure, bridges, dams, those types of things. So they're built for those types of customers, and we're looking for integration into those different vertical industries, whether it's energy, maritime, or infrastructure, to be able to replace people at work at elevation with these systems, because a huge component of the company is safety. This day and age, why is there somebody hanging from a rope or on a lift at elevation, touching a probe tip to a surface to take a measurement, or standing there with a full suit on because they can't inhale the vapors of whatever it is they're spraying? They could be safe on the ground 100 feet away, operating the system, monitoring the system while the software is going up and doing that job. The reason we tether our drones is because batteries have a limited life, and you have to land and swap them out for new batteries, so you can only get a limited flight time. If it's tethered for power from the ground, you can pretty much fly indefinitely. It's also tethered for material transfer, because material like water, for example, weighs 7 pounds per gallon, 8 pounds a gallon. If you're carrying a lot of material, it's very heavy, and that can also reduce battery life, but it also makes it much more difficult for the drone to accomplish the task. Further, often these materials are pressurized, so you would have to have a pump or some mechanical equipment on the drone. By keeping that all on the ground, the pump, the water, the chemicals, the materials, the paint, whatever it might be, the power, you're able to then optimize the use of the flight control system, the aircraft, to do a job at elevation. Part of the value of the Apellix platform is that it's extensible. So you can extend it to other capabilities, functions, features by adding things. So whether it be software or hardware, whether it's another component that you add to the software, another branch that adds another feature or functionality, whether it's another sensor that you add to the hardware to give it additional data gathering capability, for example. Those are all things that can be built upon the existing code base and hardware base that we've developed at Apellix. The example is taking a spray painting drone, removing the wand that does spray painting, and replacing it with a wand that does power washing. So those types of examples are, I'm sure, abundant, And while that's not where we're focusing as a company, we're focusing on getting our existing products into the market. That is a capability that we do have, and we do love to work with industry and with customers that have needs that we can help them with.